Hey, this is Math 8, Unit 8, Lesson 12, Edge Lengths and Volumes. Okay, so first we're going to start with ordering squares and cubes, and we have A, B, C, D, and E, and F are positive numbers. And it says, given these equations, we want to arrange A, B, C, D, E, and F from least to greatest, and explain your reasoning. Okay, so we have these different values here, and they want us to essentially to solve for the letter A, B, C, D, and so on. Okay. So for first one here, when we have a squared equals 9, if I was to consider what's the square root of both of those, I know that the square root of 9 is going to be equal to 3. So a already equals 3. So that's not too bad there. When I think about a cubed root, or something that's cubed, sorry, I could take the cubed root of both sides. So instead of square root, it's a cubed root. We'll talk about that more later on. But I'm thinking about what number can be multiplied by itself 3 times to get to that value right there. In this case, I think about 2 times 2 times 2, because 2 times 2 is 4, and 4 times 2 is 8. Therefore, that means that B has a value of 2. Okay? So we know so far that A is 3 and that B is 2. We know that okay so far. All right. Now these other numbers though aren't going to work out quite as nice, are they? Okay. So when we think about c squared equals 10, if I think about the square root of 10, I know the square root of 10 is going to fall between the square root of 9, which is 3, and the square root of 16, which is 4. Okay, so this is going to be a little more than 3. So I could say a little more than 3 in terms of what the value is going to be. I don't know exactly, but I know square root of 10 is a little more than square root of 9, so it's going to be a little more than 3. Now in terms of the cubed root of 9, okay, well, if I know the cube root of 8 is 2, and I'm going from 8, so if I know the cube root of 8 is equal to 2, and I'm talking about the cube root of 9, then I know that it's going to be a little more than 2, okay? Because 2 was what I got for the value of the cube root of 8, so it's going to be that. When I think about e squared, if I take the square root of both of those sides to find out what e is equal to, the square root of 8 is going to come between the square root of 4 and the square root of 9. The square root of 4 is equal to 2, square root of 9 is equal to 3, so it's going to be between, okay, it's going to be less than 3 but more than 2. And then finally, we got a cubed one here, and trying to get to 7, so the cubed root of 7 is going to be less than, well, we know that the cube root of 8 is 2, this is going to be then less than that, so it'll be less than 2. Okay, so let's see what we have here so far. So we know this one is less than 2, we know this one is between, or a little less than 3, okay, a little less than 3. We have a little more than 2, a little more than 3. We have 2, we have 3 itself. Okay, so let's go with what we know so far. We know that B has a value of 2, so we can put B here, and that's equal to 2. And we know A has a value of 3, so we can put that right there. There's A and B. We know that C is a little more than 3, so C is going to be a little bit more over here. And then we know that D is a little more than 2, so D can go right there. We know that E is a little less than 3, so a little less, so we're going to put E right here. And then we know that F is less than 2, so we can put F right there. So those become the orders for all of these values, kind of approximating there where those are going to be least to greatest. Okay, so you kind of take what you know about something, again looking at the square root of 8, which we've done before, and knowing the square root of 8 is going to be between a square root of 4 and a square root of 9, and you'd have the square root of 5, 6, 7, 8, you know that it's going to be closer to the 9 value, which is 3, than it'd be the 2 value. Okay, so you're probably talking maybe like a 2.8, something like that, if you had to kind of estimate there. We can do the same thing we can see here with cube roots. If I know that the cubed root of well, in this case here, if I do the cubed root of, where do I go to? Of 8, well, let's do cube root of 1. is equal to 1, and the cube root of 8 is equal to 2, then that means the cube root of 2 and 3 and 4 and 5 and 6 and 7 are all in between 1 and 2. So we can use the same kind of strategy as square roots with cube roots here, which is what we're talking about in today's lesson. So, fill in the missing values using the information provided. And we see here we have an example of a cube. We've talked before about the area of a square, and if we know that the area of a square, for example, is 16, we know we find that by multiplying the legs together, right? We know that the x squared is going to equal, in this case here, the area of a square. It's called squared because it forms the area there of a square. If we take the square root of both sides, we find that the length of one leg happens to be 4. Well, now we're looking at a cube, and we're going to do the same thing here because now we're talking about a cubed number in this case here. So if the volume is 23, we find the volume of a shape by multiplying the length and the width and the height. So we'd have the height, you might have the width, and you might have a length. Okay, you multiply those three values together to come up with a volume. So in this case here, if I have a volume of 27 inches, I'm asking myself then, what's a side length where it's the same side length that I multiply by itself 3 times to get to 27? And I could think real quick, if I think about things like 1 times 1 times 1 gets you to 1, 2 times 2 times 2 gets you to 8, and 3 times 3 times 3 gets you to 27. So a side length of 3 becomes my volume there because it's 3 times 3 times 3. And in terms of an equation, it's 3 cubed equals 27. And we call it 3 cubed because we're doing it 3 times, but it also forms a cube. That's where that comes from. All right, so that's formed by doing 3 times 3 times 3. Okay, all right, so in the next one here, we can see that I have the cube root of 5. Now to find the volume of it, I'm going to take that value, the cubed root of 5, and I'm going to cube it. Now, remember back before, when I did the square root of a number, if I did the square root of something, then it made the, like in this case here, if I took the square root of x squared, the square root eliminated the square, so I was left with just the x. If I cube a cubed root, the cube eliminates the cube root, and I'm left with just the number underneath all that, which is the 5. So the volume here would be 5. To write it as an equation, I can show that the cube root of 5, quantity cubed, is equal to 5. So that's the equation, which we can see here worked out on the third one. We can see that the volume is the number right there, which is 16, but the side length is going to be what's inside of what is actually being cubed, which in this case here is the cube root of 16. All right, so we're just making some cubes there, and that's really all that there is to it. But the point here is that we're talking about how a side length is a squared, but we're talking about cube lengths, we're talking about cube things. Okay? Now, you do have an activity that you might do in class today. I'm not doing it here because we're not in class this week. But it says your teacher will give you or group a set of cards. For each card with a letter and a value, find the 2 other cards that match. One shows the location of a number line where the value exists. The other shows an equation that the value is satisfied. So you're looking for matching cards here. So look at those cards you have, try to find the matches, and explain why they're a match. So in summary today, okay, the side length of a square is the square root of its area, right? So the side length of a square is the square root of the area. So these equations are both true. 4 squared equals 16, and the square root of 16 equals 4. And just the same way, when we think about a solid cube, the cube has a volume, and the edge length of the cube is called the cube root of its volume. And that's what we see here. 4 cubed is 64, and going the opposite direction, the cube root of 64 gets you back to the 4 value here. So there's my 4, and there's my 4. Okay, this whole thing here is pronounced the cubed root of, in this case here, 64. And there's just some other values here. Here's the cube root of 8, which is 2, because 2 times 2 times 2 is 8. I have the cube root of 27, which is 3, because 3 times 3 times 3 is 27. And the cube root of 5 is, 125 is 5, because 5 times 5 times 5 is 125. Okay, we're going to pause there, let you work on your homework. Come back and check it in just a second. All right, here we go. Homework for Unit 8, Lesson 12. So first of all, what is the volume of a cube with a side length provided here? Now, volume means I'm going to take the value, I'm going to multiply it by itself 3 times. So if I have 4 centimeters, that's like doing 4 cubed, which is the same as 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is equal to 64. And we would say centimeters cubed for the first one there. The next one, I have the cube root of 11 is a side length. I want to find the volume. So I take that side length there, and I'm going to cube the whole thing, which in this case here, the cube cancels the cube root, so we're left with just the 11. And we're going to say 11 feet cubed for a solution there. And finally, our last one, we have S. So we have S cubed units cubed for our answer for that one. Now for B, we're going to go the opposite direction. Here, we're going to find out what is the side length when they give you the volume. So the volume here is 1,000. So we need to ask ourselves what number, x times x times x, can you multiply together to get to 1,000? Okay? Now that's a nice number here, and I'm going to go ahead and try one that makes the most sense to me, which is 10 times 10, which is 100, and 100 times 10 is 1,000. So therefore, we would say that the side length is going to be equal to 10. Okay? Now in this case, 23 cubic inches, okay, and I could show this here. The other way of showing this is I'm doing the cube root of 1,000, which actually equals that. I'm showing you that real quick because that's how you solve this one. The cubic inches is this, which means that the side length is going to be cube root of 23 is the side length there. Does it have a value that I know? Nope, not at all. So I just leave it just like that. And the last one here, it's the cube root of v for what we don't know in that case. All right. Number 2, write an equivalent expression that doesn't use a cube root symbol. Okay, so the cube root of 1 is actually equal to 1. The cube root is 216. Okay, 1 maybe you don't know so much, but 6 times 6 is 36. That's 36. Times another 6 is 216. So that means that our answer for the cube root of 216 is simply 6. For 800, I thought about, well, I know that 2 cubed equals 8, and I need a bunch of zeros. So I thought, well, what happens if I do 20? And that actually works. So 20 times 20 times 20 actually equals 800. For this next one, I know the top value is going to be 1, and what number on the bottom can I cube to get to 64? We've done it before, and that's the value of 4, because 4 times 4 is 16, and 16 times 4 is 64, so my denominator is going to be 4. For E, we know that the 27 cubed is 3, or cube root of 27 is 3, and the cube root of 125 is 5, because 3 times 3 times 3 is 27, and 5 times 5 times 5 is 125. The next one has a decimal, right? So we're sitting at 0.027. Now, I know again that 3 times 3 is 9, and 9 times 3 is 27. So I can use a 3 to get there. That's the idea. The question is, what's that 3 going to be? So I tried out a 0.3. I tried that one out first. So 0.3 times 0.3. 3 times 3 is 9, but 2 behind the decimal, so 1, 2, gives me 0.09. Now when I multiply that by 0.3, I get 9 times 3 is 27. Okay, and I have 1, 2, 3 behind the decimal, so 1, 2, 3, so I have 0.027. And that matches that, so it means that for F, my value is going to be 0.3. I tried the same thing here for the next one, where I see 125. I remember that 5 times 5 times 5 equals 125, but I want to get this to be 0.000125. Okay, so when I did a 0.3, that only moved the decimal back here. It moved it only in a couple spots here. I got to move a little more than just the 1. So I went ahead and I tried 0.05. So I did 0.05 to start out with. 5 times 5 is 25, and then that's all zeros, so I have a 0 and a 0, and I have 4 behind the decimal, so I got that, 0.0025. Then I multiply that by 0.05, and I have 5 and 2, 12, and carry the 1, and we have 1, 2, 3, 4, 5, 6, so 1, 2, 3, 4, 5, 6. So I end up with 0.123 zeros and 125, which matches 123 zeros and 125. So indeed, we're going to do 0.05 for an answer for that one. Okay. Number 3, find the distance between each pair of points. Okay, for the first one, I see that they have the same y value, so all I have to do is find the distance between a 5 and a negative 4. So I have 5 on one side, 1, 2, 3, 4, 5, and a 1, 2, 3, 4. So the distance from there to there is 5 minus a minus 4, which equals 9. And for the last one down here, then we could put it on a little grid like so. We have point L at 0, 0. And this one's going to go over here to negative 21 and down to negative 29 and put a point right there. Which means that if I was to draw a triangular shape, I could go down 29 and over 21, and that would then help me to figure out what the missing value is going to be. So I would do 21 squared plus 29 squared equals c squared, because that's my hypotenuse right there. 21 squared is 441. 29 squared is 841, all equals c squared. When I combine those together, I get 1,282 equals c squared, which means then that the square root of 1,282 equals c. So kind of a funny answer, but that is the correct answer right there. Okay, next it says here is a 15 by 8 rectangle divided into triangles. Is the shaded region a right angle triangle? So is this a right angle right there? The question is that going to be a right angle? Now the way we would know it's a right angle would be if this times this squared plus this squared equals that squared. So let's see if we can find out. To figure that out, we have to figure out our different lengths. Okay, so let's see what we can do. Now this length here is 8, which means this length right here is 8. And this combines together to be 15, so I know that length is 15. Let's find our missing value here. Here, this first one's not too bad because this looks like a 3, 4, 5 triangle. 3 times 2 is 6, 4 times 2 is 8, and then 5 times 2 is 10. So this length right here is going to be a 10. Put that right there for a 10. And I can do that because I know that's a right angle. It's a rectangle. Over here, I don't have a 3, 4, 5. It doesn't quite work out that way. But I can do 8 squared plus 9 squared equals that c squared. So I have 64 plus 81. Oh, I'm way off the screen there. Wasn't paying attention. Sorry about that. Sorry, back to what we had before. 8 because that's 8, 15 because that signs to be 15. Here I have a 3, 4, 5, so times 2 times 2 times 2 makes that 10. So now I'm coming back to this triangle. I have 8 and 9 and a c. So 64 plus 81 is going to be 145 equals c squared. So the square root of 145 equals c. So this value right here is the square root of 145. So if this is a right triangle, then this leg squared plus this leg squared will equal that squared. So let's take a look. Square root of 145 squared plus 10 squared, does that equal 15 squared? Well, let's find out. Square root of 145 squared is 145, 10 squared is 100, and 15 squared is actually equal to 225. 145 plus 100 is 245, and that does not equal 225, so we would say not a right triangle. Because it's not equal, it's not a right triangle. If it was, it would be right a triangle, but it's not. All right, and finally here's an equilateral triangle. The length of each side is 2, so we have 2 there, we have 2 there. A height is drawn. In an equilateral triangle, the height divides the opposite side into equal pieces. So this is 1, and that's 1. Find the exact height, so this height right there. So I know I have a triangle which has I don't know what that is, we'll call it x squared. So I know 1 squared plus x squared equals 2 squared. That's my hypotenuse right there. So 1 plus x squared equals 4. We subtract 1, x squared equals 3. So x equals the square root of 3. So this is the square root of 3 for the height. Square root of 3. The area is going to be found by doing what? 1/2 of the base, which is 2, times the height, which is square root of 3. 2 times 1/2 is equal to 1. So we're left with just the square root of 3 is the area. There's a challenge question here, which I'm going to leave for you. Using x for the length of each side in the equilateral triangle, express its area in terms of x. So see if you can write an expression for the area in terms of x. I'll leave it there. That's it for today, and we will see you next time.